So today we are going to discuss the next chapter, operating system and structure. So moving forward, we will be start working on Linux system because there are a few things we have to look at how the operating system works, what are different features, how we can interact with an operating system. So Linux is one system which is more terminal based, whereas Windows operating system is more GUI based. Mac is in between both, so it provides a beautiful GUI based interface and also provides you with terminal with which you can actually do most of the stuff. Linux is one which basically allows us to interact more frequently with the operating systems. You'll use some commands to look at different files, which is ls command. Then we go to some particular folders where you could find some information about the system. And then we would also use strace command, which would actually show you how the system calls are being executed. So coming back to the starting thing is what are operating system services. So as you know, operating systems main priority is to provide the user with the responsive environment so that the application which a user executes should run in a smoother manner. With the operating system should provide you an interface where you find easy to use it. So first of all, the first important part is user interface. All of you are aware about GUI based systems, so it is more like Windows system where for each and every job you have an interface, graphical user interface for doing most of the stuff. Even for copying a file from one place to another place, you will find there is an interface. You can right click and you can copy and then paste it somewhere, or drag drop is one option. Command line is whosoever loves terminal based communication in Windows. If you click start and type in CMD, it will show you the terminal there. And in Mac, you can click Launchpad and type in terminal. So it will show you the terminal. In Linux, Ubuntu, the image that I have given to you is basically terminal based Ubuntu. That is basically terminal based here because you don't see any GUI. Ubuntu image. I'll try to write more clear. Okay, so terminal based Ubuntu image is running. Bash is basically a shell. We will talk later on. Bash is a shell, and a shell is basically provides you with some functionality that you can interact with your operating system. Like if you want to copy something from one place to another, from one file to another file, it provides you with the command cp, and you just write down cp file 1 and file 2. It'll copy everything. Like we will talk more about it today, and that's what where we will be applying strace function. So bash is a shell. Then you have zsh. Then there are many, like dash is shell, then corn shell. There are many shells available. So each one has a different kind of commands and facilities which are available. So user interface is one. So we see that nowadays we have touch based interfaces. So you can just touch on your screen and you can execute the programs as you want rather than mouse based or command based programs. So now interfaces are multiple. So whosoever is a power user, the power user is one which who wants to do the things more programmatically. In that case, terminal based interface is the one which they love most. because if you use the GUI base, you don't have any control on what to do. But on terminal based things, you can stack it, you can put those commands into a shell script, and you can run all that stuff. So as we move forward, you will get to know more about how we can use these commands more effectively. So user interface, then there is a program execution. So one set of operating system services provide some function to us. So one function is user interface, and other is a program execution. The system must be able to load a program into the memory and run and execute that. So now either it runs a program normally, or it runs it abnormally or abort that particular program. So based on that, whenever a program is loaded into the main memory for its execution, then either your program run completely or it abort based on n number of reasons. It may be an error, it may be a disk error because your file is not available, or it may be divided by zero error. There are many type of interrupts that could actually stop and abort your program. So program execution is one thing which is provided by operating system for execution. Now, IO operations, running a program may require IO, so input output devices, and its operation must be provided. So we studied about device drivers and controllers. So these are device drivers and controllers, so 1 and 2. So drivers, which are part of operating system, which we install onto operating system, and CPU communicate with the drivers. Controllers are basically onto the hardware, which communicates with the driver and instructs the device to act accordingly, whatever is being said. Now there are, moving forward, we have file system manipulation. As we discussed about that there are read-write permissions for directories. If some of you might have worked on Linux system or Ubuntu system, then they are aware about the file permission. So each and everything on Linux is called a file, and each file has certain permissions. So there are permissions for the owner of that file. So owner is the one who created that file. Then there is a group to group of, like we as in a CP386 has some permission onto that file, and then there are permissions for others. Like, so if you have worked on PHP and other stuff, so you know the permissions. Like whenever you post something online, you have to make it you have to set the permission so that other users can actually see it. So all those permissions are also come under file manipulation and file handling. So this is also one feature that is provided by your operating system. Now communication is how the communication is performed. So whenever we know that a program under execution is called process. So whenever we have a program, let us suppose xyz.c, when we compile it and load it into the memory, that becomes a process. So when it becomes a process, it start and load it into the memory, and then the CPU would start fetching its instructions and keep doing what it says until it is either complete or abort by a trap or interrupt. So now when there is only a single task system, there is only one processor, there's only one task, all good. Just one task is given to the processor, it is running and it will complete. When we talk about multi-programmed system or multitasking system, there are more than one task running at same time concurrently. So in that case, it may be possible that there are processes who want to exchange the information. So let us suppose there is a process P1 which wants to share some information with P2. So when we talk about sharing information, it may be, let us suppose P1 is updating a variable X, and this X is required by P2. So whenever this kind of information dependency is there. We have a dependency graph. So when this is done, P2 has to read it. So it may be possible that P1 is actually communicating whenever it is done that I have updated the value of X. Now P2 can actually use it. So there are different type of messages which could happen over the time. So it could be shared memory or it could be your message passing. So message passing is called MPI, message passing interface, where two processes share the messages. This is used for small size packets. And then the communication could also exist through shared memory. So in that, whenever we have a large data, we prefer that the processes should actually share the memory, piece of memory they should be sharing. So it depends upon the type of the process and also the size of the data, which decide upon what type of communication should be between two processes. Now, communication is the operating system provides us with these facilities and functions. Now, moving toward error detection, this is also a very important part, and the feature and the service which is provided by OS. So whenever CPU is running, executing, so it's basically pulling some data uh, from the memory. Now, memory CPU is hardware. Your main memory is also kind of hardware. So it may be possible during the communication there is an error. So if you have studied microprocessor, you might be knowing that the error could be based on the parity bit and other stuff. So I'm not going into detail of that. So error could be hardware error, or it may be uh, a software error. So there could be different type of errors that could come in, like an arithmetic overflow or illegal memory location access, or sometime it may be there that the program is unexpectedly terminated. So in such situation, your operating system has to take care of what exactly uh, uh, take care of the error and take necessary steps. So we have discussed something on it, like it creates trap for certain type of errors. So allows the operating system to take necessary action. Okay, so another set of OS functions. So whatever we have discussed, it's more like user interface, which are like helping user. And there are some functions which are inherent to operating system, which are needed by operating system to work efficiently. So topmost is resource allocation. This we have already discussed. That there are many type of hardware things those are running, so we have to manage it. So this is one functionality to keep track of which user and how much they have used, what kind of resources they have used. This is another functionality. And then we have protection and security. So the owner of the information stored, multiple processes are running, multiple users are using the same system, so we need protection. So it protection allows us to basically access the system with authorized for the authorized processes or authorized person. And now this could be something like protection of viruses. If you remember, we discussed about denial of service attacks and other viruses, worms, which can attack your system. So some functionality is there. So this is a high-level diagram of your operating system services. So here is the hardware, which is just lying underneath. And then we have certain services that your operating system is providing. So those are program execution, I operation, file system, communication, resource allocation, accounting, error detection, protection, and security. These are some, not a complete list of what services an operating system provides. But yes, these are most important services that an operating system provides. Then we have the most important part is system calls. So system call is an interface to the programmers or users who want to use the services which are provided by operating system. So here come the user. User uses different terminals, different interfaces. Based on that interface, it actually enables certain system calls. Now these system calls explains the functions which invokes these system calls invokes the these services, any of these services, multiple time, single time, it depends like. So system calls provide us a mechanism to invoke system services. Now we have different interfaces for it. So command line is one interface we implemented. There are many shells which we have shortly discussed. So bash is one which is more POSIX based compliant terminal. So POSIX is portable operating system interface. So most of time we will be using these POSIX compliant commands, which would actually interact with the operating system. So Ubuntu is basically a POSIX based operating or compliant or operating system. Ubuntu, Unix, other Linux, and mostly the Mac OS is also one, which is post POSIX based compliant. So most of the commands which we will be seeing, those would be based on POSIX. Those are POSIX compliant, and they are able to run on different operating systems. So this is a standard which was actually uh, developed by IEEE. So they wanted to create the set of commands by which can be executed on different operating systems. So let me just pull another file so so that we can see. I think most of you are familiar with it, but still I want to show you some of the files or the commands. Should I? Please let me know. Should I? Okay, so this is the first file, which is basically not a complete list of Linux commands. So for the commands, the what I say is how you write a command is based on. Let me share my text off, and that would be better. So can you see my screen? Okay, yeah, thank you so much. Thanks. Yeah. So basically, your command is there are a set of commands that you can use. Now, how to type in the command is, so I'm into my Linux system. So you can see it's OSC@Ubuntu. So that's its full name or the full qualified name of the Ubuntu, and this is my username. So this is how it comes. So this is called prompt. So I can run ls command. So there are certain features and attributes that we can use along with this command. So ls is one command, and then we have its arguments. So L is one argument. So if we can see the difference when we pass in different arguments, your command would present different data on in front of you. So LSL is a command which actually shows you the user ID, the space it has taken, and when it was first created. So there are different commands that we can use. Let's suppose I want to see till when my machine is up. So this is one command that I can use. If I want to say date, what is the today's date? So it will show me this. If I want to see the calendar of 2020, so I can use this cal 2020, and it's showing me this, the 20 is today's 20 date. So there are many that you can use, and if you stuck somewhere, then you have a command man. Uh, I hope this is visible to everyone. So clear command is used to clear your terminal. So you can type in man, and then you can type in ls command. So it will actually open a user manual. So help manuals basically. So this manual would actually let you know that what is the name of the command, what how to use this command. So there are different options that we can use. Now there are many mandatory arguments that we can use. So here you can see either you can use a single dash A or you can use double dash all. It is up to you what you want to use. Each command attribute or argument would give you different entities. Like A, if you want to see hidden files, hidden files on Linux system are the one which starts with dot. So if you want to list all the commands or even the hidden files, so then you can use A. So this set is actually telling you what features or what arguments you can use along with the command. So there are many you can use. So this basically you can use it programmatically to do it. So to come out of this, when you are working in terminal, Q is a button which when you press, it'll bring you out of it. So press Q, you will be out of it. Okay. So this is one. Now there are few that would show you how much is the disk space, what memory is free, then disk used, how much it is used, and then there is free, how much memory is free. There are many that you can use, and then there are file commands further you can use and experiment it. Please try to run all these commands one by one. It will actually help you out to get more into Linux system. So I try to explain something here, and then there are some process management and process monitoring commands. So PS is one which would actually show me that what are the processes running. So if I want to see all complete list, then there are attributes that I can pass. So P, AUX, it'll show me all the commands. So PUX, I want to see only certain limited commands. So I can use grep is one command that I can use. And I pass in, I want to see where SSHD is coming. So I just wanted to see those commands. So you can see here, it actually show me these are the processes, the process ID, who is the owner of that particular process ID, and where it is being called. So this is the process which is being running basically. So we can use these process IDs to look further into it. This is called PID. Okay, so there are many, some needs special installation, some are not installed. It may be possible. Then we have chmod. So I consider that all of you know about file permission. So file permission is, as we started discussion about each and every thing, even directories, files, devices on Linux system, each thing is kind of a file. And each file has certain permissions. So that permissions can be seen here. If I see LSL, you could see the permissions here. So these are the permission, like anyone, I can execute, read, write, execute. Others, group can read, write, execute, and others can only read and execute but cannot write into this file. So these are the file permissions that we basically, each file has. So you can see it. If something is directory, so I go back, so I do LSL here, sorry. So you can see in front of directory, you will see D. So that D would be actually telling you that this is directory, this is not a file. So that distinguish is there, but mostly your Ubuntu system, Linux system would consider everything as a file. So same kind of permissions are there. So first three are basically your owner permission, then other permission, and then group permission, and then the last three are others permission. So that's what is basically happening. So if we pass in C chmod, so chmod basically. So it's 777. It means it is enabling its octal number basically. This is an octal number. So I hope you all are aware. Octal number is represented now. The binary equivalent of this 777 is 111, and that means this one, and this is one. So read, write, and execute permission for the owner of the file. So this second 7 is for 111. So read, write, and execute for the others, and then we have 777 when we do 777 here. So it will also be changing. So let's do that. Smart 777. I don't know if I'm wasting your time. Sorry for that. So if I see ls now, let's see, you can see the change here. So you can see the change here. So others can also write into this particular file, whereas this is a binary file anyways. Uh, so this is how you can actually go. And this is very, very important for you guys. If you are using uh, Windows system, you prefer to use PuTTY. PuTTY is a software which would enable you to connect to remote server, or you can use a terminal. But for Windows, you have to install SSH client basically. On Mac and Linux, it's already installed. Okay, so you can do SSH, then the user and host name. It will connect you to the system. Now, everything has become remote, so most of our server and computation is performed on servers. We just use them as an clients basically. So SSH enables the secure shell, and it enables you to connect to a server securely. Mostly you will be using this when you are studying cloud computing and all that stuff, managing your infrastructure, software as a service, or EC2 instances. So you will be doing SSH to those services. So there are different commands, and then there's one command that is for compression or decompress the file. So this would be very useful and helpful whenever you download something. So tar is one command which is already onto your Ubuntu system, not on Windows system. So that would be available. If you want to make your Windows system work like and you want to communicate and use the command same as of Linux system, then there is a platform called Kaigwen. You can search this out, Kaigwen. It will be very helpful for you and make your Windows system. It is a terminal basically for Windows, and it is a POSIX compliant and would convert your commands which you write similar to Linux into Windows system. So it basically provides an interface, but some people are more familiar with Linux system, so they prefer to install Kaigwen on Windows to use it as the same for each and every operating system. Okay, so now the installation. So usually whenever you download binary files from different locations for open source software, they provide you with the binary files. So those are uncompiled version of the file. So in that case, you basically can use these commands to run, and this is for installing some packages onto Ubuntu. There are a few shortcuts, and there are pipes are very important. I will just discuss this. Pipes enable you to connect different commands together. So whenever you want that the output of one command should go to the next, so whenever you want to dump your database for MySQL, so you can use pipes. So these are pipes. So VA editor is one which you have to do it yourself, and then Makefile is one that you have to do it yourself. So I will quickly wrap up here and then move to next. So this we have discussed in the terminal. Let me start sharing my screen. It takes some time. Sorry for it. Up to yeah, Khalil, only up to what has been discussed today. Only that would be included for the quiz. Don't worry about it. So we are making it and we are here. So I think it's more important that we discuss on learning what we are discussing. Okay. So moving forward to what has been. Are you able to see my screen? Yeah, okay. Thank you. Okay. So moving forward, we have system call. So system call is basically a method by which we can actually communicate and use the services provided by OS. So for Linux, the services or system calls are written in C basically. So C is the one which is used for writing these application, the system calls, sorry. So because the system calls are there, so how we use system calls, that is through API. So application programming interface, which provides us the documentation to use different functions. And these functions invoke different system calls. There are three most common APIs. So basically for Windows, we have Win32. We have for Linux system, we have FOSIC API, and which is all for Unix, Linux, and Mac. So if you worked on Java, you know that Java API is available also. So there are plenty of APIs information which is available for you guys. Now we will run through again an example for strace. So let me quickly jump back to the system. So here I will communicate with you. Okay, now you can see my screen. I hope you can see my screen. Now here is one function which is called strace. So we are just going to see the list of commands or system calls that a particular operation calls. Okay, so you can see ls. So here it lists, strace is a utility that lists all the system calls. Now it's not readable, but I would like to make it more readable. So you can see here the single ls command makes these set of these many calls. So these are the calls: 7 call, 2, 9 call, and there are 11 close calls, 10 f stat calls. So all these are system calls that a single simple function calls. So you can see even ls makes 95 total system calls for performing ls function, and ls function is just to display what exactly it is. So let's say we are doing ls. See, if we added an attribute lsl, I can do that. strace c lsl, you can see now the system calls have been increased to 270. And let's try with an attribute a. So you can see there are only fewer system calls. So all these are system calls whenever we run a different operation, and shell provide me the facility to interact with operating system services. They have inbuilt code written for ls command. It actually issues invoke those system calls, and those system calls return it back to the terminal to showcase some input. So what is happening? The process is we basically given some information. We are typing something here, ls command. This command goes to the operating system, your basically interface, or to shell. It creates a list of system calls which are needed for the performance of this, and then return back and write back onto my terminal. So there are a list of operations, those are happening here. So let me show you. There is a file called file copy. This file copy I would share with you. I will share with you the executable file, this C file, so that you can actually see the code, and then you can compile this file, and then it'll become file copy. Now I'm just going to run this file copy. So it is asking me the name of the first file, and then asking me the name of the second file. So basically it's a C code for equivalent for CP command. Okay, so let's see how this happens with strace. So strace, I just want to see the list of system call it performed, test, and test. So you can see it performed 36 system calls. So that includes read, write, open, close, lseek, memory, product. There are many, so that we will slowly discussing on those system calls. So my point was whole point was to show you that even a simplest operating system, your simplest command would actually invokes multiple uh, system calls. Okay, so quickly over to it. Now you can see there's the system call sequence. So there are different system calls which are required to acquire the input file name of the file name. If the file name is existing, then it's okay. If it does not exist, from where to copy, then it will actually abort the operation. So these are all different system calls. So acquire the input name, this is one system call. Write prompt to screen, ask from user, another system call, accept input, another system call, acquire file name of output, another system call, so on. And if the input file does not exist, this is another system call. Down the line, let us suppose N1, and based on that, if it is aborting, it will send a non-zero error to the operating system, and based on that non-zero error, your operating system would display on the screen that a file is not existing. So if this is the file is existing, it will create an output file. This is another system call. Okay, if file exists, then it will abort, and it depends upon operating system to operating system. If we use cp command, then it will simply create and override the existing file. So it will not basically abort, it will just delete the existing same name file and overwrite it. Then it loops through the file from input file for each and every line and write it into this. So until the read fails. Read may fail if there is no device memory exists, or there is some other type of error, or you don't have an access to the output file. So in that case, your program would actually fail. So once it is done, it will completion is done, it can write onto the screen that it is done and then terminate normally. So when this process would terminate normally, it will send a zero signal. So zero code would be sent, which would enable the operating system to say, hey, it is basically basically this operation is successfully performed. I'm just looking at the question of Harshal. Quick question: would the number of system call increase if we have more number of files in that? Certainly. So it depends, like how many operations we have to perform. Like I have to locate the file onto secondary storage, then open that file, then see the contents, then start performing the operation, and then start outputting onto your screen. So whenever I'm sending some data, I'm writing something onto the terminal, it takes the the information, that is one system call, and do the operation, there are other system calls, and then write back onto my device. So my screen is basically an IO device. So whenever my CPU has to write onto the CPU, my screen, it has to access that resource because it's showing the terminal, and then that's another system call. So whatever is happening inside your operating system, there are certain services operating system is performing. Now, it depends upon operating system to operating system, which provides us the API. Now, API is a documentation which provides list of functions to the programmer if somebody wants to invoke those operations. Like if you want to perform open, then there is one function in C which is written, and you can use that C function to open that particular file. So this is how actually moves. So system call is an interface, and it's a list or the library or library of functions which are provided by the operating system to perform the different operations with the services. Why we need system calls? Why we can't use directly the system calls? So basically, that in that case, it is more complex. So I will be coming to that point too. So you can see here is a standard API. This is standard documentation for read function. Now for read function, it says if you have to call this function, you have this return value, this is the name of function, and these are the list of attributes you need to pass in. And it also need a header file like this one. unistd.h is a file which is needed for using this read function. So this is a C program, or basically you can use this way. It will return you some input, return some output whenever it is called, whenever you pass some information here. So I think pretty much I'm able to explain what exactly the system call is and what it does. So system call, for each and every system call, there is a number associated with each call, each system call. There is a number existing. So system call interface. So let me show you that their interface. So how this happens. So this is basically something this user application. A programmer writes the user application, and then the programmer uses the APIs. The APIs are used, and when the API, the open function is used, it will actually go to system call interface. Now this system call interface would actually convert, look at the system call, convert that system call into the operating systems beneath the system call. So this API is converted into the actual system call by this system call interface. How it manages, so there is a number associated with each and every system call. System call interface maintain that table index according to these numbers. System call the interface invokes the intended system call in OS kernel and return the status of the system call or any return values. So I'm saying that the system call is basically given to a programmer as a function. So that function takes some arguments. Let us suppose the file name, the output file name. Then it basically tries to invoke the system call interface tries to invoke the actual system call of the operating system. Now, why does we need system call interface? This is the answer to this is portability. Like if you have written one program for one operating system, you can port that program to another operating system if they use the same system call interface. This makes your program portable. Like all of you are writing Python programs, you can run the same program on Linux, Windows, as well as Mac. So there's no problem how this is happening, because there is some system call interface which is called RTE, runtime environment. That runtime environment would convert your program instructions into the actual system calls for the operating system. I hope I'm able to explain it. So caller needs to know nothing about how the system call implemented, just they need to obey API. So whatever API is given, we have to obey this particular thing. That's the only condition that is required as a programmer. So most detailed OS interface hidden from the programmers by API. So even the programmers don't know what exactly the system call would be, because they are just using APIs. And it is managed by runtime library. So RTE is one. So runtime environment is provided basically. I think this is clear. Uh, so moving forward is there are some, not only we need to identify the number of the system call, it may be needed that the system call requires more information, like passing some parameters. So when we pass some parameters, it could be simply passed as a function to the function, or they may be stored on a block of memory, and then we just pass on the address of that particular block, that the parameters which are required for that system call are stored on that particular block or table or in the memory. And let me show you the next screen. So here we have X parameters to be called for a system call. So we load this address, which actually hold the address of the block. So basically this is operating system, and it knows now that this block address has been passed, that the instructions or the data which is required by the system call is placed here. So those can be popped up one by one from this particular block of memory. And this is how basically your system call interface share the information with the operating system call and pass the parameters. Any question? Is it fine? Anyone there? Is it fine or heavy or what? Okay, thank you. Thank you so much. Yeah, appreciate it. Yeah, it's a bit heavy, but because I always believe if you have visualization of something, you would actually learn better. So that's why I started with the Linux. So at least you know that that basically when you are working with different the files that I have created for you is already giving you some insight and on how to use your Linux operating system. Okay, so okay, moving forward, there are different types of system calls that we use. So just to give you, we start with the first type of system call, which is process control. This is the most important type of system call. So the process control system call. So it provides us functions to create a process. So it provides us function fork to create a process. It provides us function to terminate the process. So whenever it terminates a process, either it generates code 0 for successful termination or not equal to 0 for unsuccessful termination. So based on that code, operating system would take necessary action onto that particular process. So this is provided by this part. Whenever a process starts, there needs to be that operating system can end and abort that particular process. Okay, so if your process run into a problem and gets aborted, then its status is dumped into memory called core dump. Here I just want to add, if your kernel crashes, then the dump of the memory is called crash dump. So why do we need it? So we need it because we want to see what has happened to my process or to my operating system. So that is one thing that is needed. So all the processes, whether they are successfully running or they are successfully executed or they terminated or aborted, there are log files for each and everything. So I've shared that those commands and file system files locations where you can see for different types of logs for the processes, for the operations those are being performed onto your system. So I hope now I will not go into that because I have little time. So if you have to control the process, you need these attributes, and there are system calls for that. To control the process, I need to know I need to know how many parameters it has. I need to control those parameters, and those parameters would actually help me in controlling my process. Okay, so now if you remember, we discussed about timer. Any one of you remember that timer concept? Okay, so timer is basically allowed for each and every process so that it should not take the control of the operating system for long. So timer is always initiated. So this system call would actually allow us to set up that timer limit. And then there are wait and event signals that are used to look at certain features, so when to stop and when to start your process. Uh, Allocate and deallocate. So this is another systems call to allow allocate memory to the process. Now this is dump. We have already discussed it here. Debugger is basically used for debugging, and we use to look at the log files. And the logs are basically whenever we discussed about, there are two types of communication that happen between the processes. One is MPI and other is shared memory. So whenever there is MPA, there is no lock needed. When there are shared memory concepts, so two processes are actually trying to access the same location. In that mechanism, we need to have a locking mechanism so that only one can write into that particular location at one time. So that is also provided through system calls. Okay, so now just I would like to showcase you few. Like here, this is a single tasking system. So this is MS-DOS. Here there's only one process which is running. So we are not bothered about locking mechanism. When we have multiple processes running at same time, they may be sharing the memory. There would be some question like threads would be sharing the same memory space. Then we see the shared memory model, and then the concept of locking would come into picture. Okay, so moving forward, we have the system calls for file management. Like you have to create the file, delete the file, open and close the file. I have shown you guys how the strace is basically telling you when open is called, when close is called, when create is called. There are different type of system calls available. So I'll just quickly try to wrap this up. So there are system calls for read and write and reposition. So reposition is required to jump to certain position on the file. So once that is done, so there are system calls for device management. There are many IO devices, those are connected. So we need to basically work on those IO devices also. For that, we have list of system calls. So one is request device system. We call it a request for like whenever it wants to write something into it. And then the release device. So whenever some process actually releases that device, it will be shown here. So read, write, and reposition, it's something similar. So if you remember, I stated that files and devices are considered as files on Ubuntu. So basically, there are certain system calls which are common to both. So then we have get a device attribute, set device attribute, and then we have logically attaching and detaching the devices. Okay, so if we have, like in particular for IO devices, we could run into a problem called deadlock. This is a full chapter how to avoid deadlock, because there are more processes which try to acquire the same device multiple times. So in that case, we have to look for to avoid these deadlocks. Now the next is information maintenance. So information maintenance is basically providing you with the status of the process. You want to see what time it is. Uh, uh, you want to see the transfer of the information between the user, program, and the OS. You want to see the version number of OS. So all that would come under information maintenance. So we actually we can see this whole information from the dumps or the log files which are created. If you want to find out some information for the system or for the process, everything would go into the dump or log file. There is one folder on your Ubuntu machine that is called proc. So when you go to this particular folder, you will see list of subdirectories and executable file. So all those executable files would actually provide you with the current status of the processes. So if you can go to your CPU machine, and then you can actually look into it. I'll try to next time to collaborate both my terminal and my iPad together, so that it is easy for me to navigate. Sorry for today. Now the communication, as we have discussed, there are two types of communication that we have. For communication, there are a list of system calls available. Let us suppose I have a client, and that client wants to communicate with the server. So how that goes, like the process should actually have a get host ID, get process ID. These two system calls would actually enable my process to wrap up its message that a process ID this and host ID this. So our host ID is your IP address that goes into TCP/IP mechanism and all that. I'm not going to touch that. So you have host ID for and as well as the process ID. This goes to the some server process which has a system call running accept connection. So that accept connection would actually accept the information, then send it to the other processes to unpack the message and do according to that. So there are system calls. So whatever you want to do with the computer system, whether you want to send some information, you want to receive, you want to store, so whatever you are doing, it is basically done through system call. So system call is provided by operating system, or do we have our own interfaces, system call interfaces, which actually change my function call into the actual system call of the operating system. So there we have then shared memory models to gain access. So there are different system calls for this particular part also. Just in shared memory model, when we have shared memory, so there are two types of, let us suppose we have shared memory create system call, and then we have shared memory attach system call. So these are the two system calls that we used. Now, whenever we have a shared memory, there is another concept, read after read, read after write, write after read. So this would actually another system which is beyond the scope of your class, but this is also used for when we have a shared dependency of the memory. So there are system calls for doing that. Now for protection, you have system calls like get permission, set permission. Can you tell me which command today we run for setting up permissions to the file? Can somebody tell me? Just quickly. Exactly. Thank you so much. So we have certain system calls written. So fork, exit, wait, open, read. So these are the system calls that we would be using for doing our lab work and assignments. So these are certain system calls that you will be using. Further, C programming, how it invokes basically a system call write. So you're writing stdoh. So here you call printf. It calls the standard C library. That standard C library converts this printf into actual system call, which is write system call. So it will write something onto the device. So printf reading would write into the device. So this is how we actually interact with the system and system call. Okay, so just I'm quickly wrapping this up, and then we go to the quiz and the poll. I just want to touch base here because other stuff is just a theory, so I don't want to go into that detail. So I want to know that if you all are aware about compiling a program on using GCC. Are you aware about this? Great. So this is basically linker loader. Then it makes nice things simple. So we have main C file. So then we compile with GCC. The GCC is a compiler which compile this file, creates an object. This is relocatable object file. So this is created, and once we do O, it'll actually create me an executable file. So all of you are aware, for Windows it will be .exe, and for Linux and Mac it will be .out file. So to run this, I'll just do this particular ./main, and it will actually upload that into the main memory. So the loader's job is to load your program into the main memory and put that into an actual address space. So where CPU has an entry point from this executable file, which would give the entry point is the first instruction that our CPU has to run. So this would actually provide that particular entry point to the CPU, and it will start running your program, whatever it is asked for it. So I think this is enough for today.